Hey everyone, this is part 3 of my conversations with Mike Levin. I'm back in Utrecht. Spring is trying to come, although it's rainy, and I'm thinking a lot about these ideas today, so I wanted to just go ahead and post it. For those of you who haven't listened to part 1 and part 2, it's absolutely okay. It stands alone. This one we go a different route and riff a bit on how we can really understand dichotomies, either or, while holding them as important tools at the same time. And we talk about nature and the environment, and we talk about robots and what that word really means, and we talk about healing and how, in a sense, trying to do something or give something or open some path that is healing is really the point of all this. His work and his very scientific, engineering, practical approach, and me and my more philosophical, theoretical approach. And I think we get to a place that's really nuanced and important in this interstitial space between all of these words and the way we use them: ecological, technological, robots, beings. People get turned on and off by those in different ways, and we try to look at that a bit here and understand why these terms are so meaningful and important, and also can be so divisive and difficult, and also just what the big picture is, as I said, which again is maybe best understood as healing, experiencing this earth and one another and all these amazing beings in a way that can nurture us and them and still be exciting and motivating, while at the same time is practical and takes into account the messiness of it all. So I won't go on and on about all that, but this is another research conversation with Mike, and I hope you enjoy it, and I'm really glad you're here, and I hope you're having a beautiful day out there. Hi, Mike. Nice to see you again.
Yeah, good to talk.
Yeah. I thought this time, instead of talking about specific ideas and papers, I wanted to sort of try to zoom out a little bit and think about this orientation of beyond dichotomy. And to get us going, the question is, how important is art and nature in your life?
In my personal life.
Yeah, daily life, everyday life, the way that you kind of, yeah.
Yeah, nature is hugely important. I spend a lot of time outside. I do some nature photography. Mostly that's a kind of, for me, it's almost a kind of meditation because it keeps you just busy enough to be doing something with your hands and so on. But really, it kind of lets the mind go. So yeah, I like sunrises a lot. I'm usually up before sunrise, and by the time the sun is coming up, I'm outside walking around and
Oh,
so on.
really? Yeah, I saw you've had quite some beautiful pictures. So I guess you don't think of yourself as a photographer, but I mean, or do you? I don't know.
I don't think of myself as anything specifically, not really. I just do stuff, and I think I enjoy it a lot. That's time when I can do a little bit of thinking before the rest of the day starts up with all the meetings and the discussions with people and so on. But no, yeah, to me, nature is very important. I do a bunch of gardening. I grow stuff. Yeah, I kayak, things like that. Yeah, nature is huge for me. Art, I enjoy art. I appreciate it. I'm unable to make any art.
The help of AI, you can.
Yeah, that's true. That's true. Yeah, that's true. But really, yeah, I enjoy art. I know what I like. I don't have any training in it or any expertise in it.
Yeah, I was just talking with Karen. I think you know Karen from the Meaning Code.
Oh yeah.
Yeah, and she was telling me that, we can all do art. I think she started when she was in her 50s or something. So she sort of scolded me that I shouldn't say I can't do art. But so I'm sure I should scold you too. I'm sure you could do art if you had time for it. But I think you are in a way. But the reason I bring this up is because often in these kind of circles, I'm working in a lot of different worlds, and I know you are too. And sometimes it can seem like the ecological and the technological are at odds. I know we don't think they are, but at the same time, there's a lot of terms that are used in both those worlds that are very similar. Something like regeneration, for example. There's the whole regen movement where it's all about building the environment to co-evolve with natural systems, for example. So there's actually a lot of connection, but in my experience, it's quite often there's a kind of defense against technology or AI or manipulation on one sense, as not being natural somehow, and so not being ecological. And I feel like that there's a confusion there. So I guess just to start, I wonder if you think about this in a broader sense, because when you're doing things like depolarizing surrounding tissues to kind of, increase optic nerve, you're manipulating a certain ecology, right? Or an environment, or you're changing it. I don't know if manipulation is the right word. And you're also often doing this internal, external kind of stuff. So I guess I wonder, like how that strikes you first. And then I want to ask about if you think there's a kind of continuity in the way that you often talk about scales and continuums, in terms of these like bigger groups of people doing work in ecology and technology.
Mm. Yeah, a few things there. So one is when we do these bioelectric kinds of modulations where we make eyes and limbs and fixed birth defects and stuff like that. The reason it works is not because we're so smart. The reason it works is because though we are exploiting an interface that cells offer to us. The reason they offer it to us is because they offer it to each other. This is how cells hack each other's behavior normally during development, during evolution. None of the things we do would work if they weren't endogenously meaningful to the cells. The signals, the reason that we can make, let's say, an extra eye out of a bunch of gut cells is not because we know everything there is to know about all the micro components of being an eye. We actually provide very little information. We say, build an eye here. It's a very simple signal. It's the system itself that's smart. And once it gets that signal, there are all the processes that build an eye. And then crucially, they stop when they're done. So that's a lot of, and there's other competencies there that I could talk about. But that's why all of this works, is precisely because the system is poised to receive inputs like this. I view all of this as on the spectrum of communication and collaboration. I don't think we're micromanaging the cells. I don't think we're forcing the cells. We are making suggestions, literally, because sometimes they take us up on it and sometimes they don't. And all of that understanding it that way really helps drive new discoveries. This is not just like fanciful painting these things onto a mechanical system that's well described by mechanical events, because it's not. And so that's an important piece to this, to say that this isn't natural. Actually, if it wasn't natural, none of this would work. It's absolutely natural because that's what cells are doing and tissues are doing to each other. Now, going one step deeper, I actually don't like this natural technological distinction at all. I mean, I don't like a lot of binary distinctions, but that one in particular, I think, is pernicious for a few reasons. One reason is that everything in biology is hacking everything else. That is the natural world. Every cell, every organ, every parasite, every mate, every predator, prey, they are all trying to find the signals that make the world around them do what they want them to do. We are also a product of that so-called natural world, so we are also a product of evolution. And the fact that we are now able to do this in a self-reflective, rational way, whereas other bioengineers like wasps who make galls out of plant cells and so on, they do it at a lower level of cognition, but we are part of that same chain. This technology is not in any way alien. This is exactly what biology does all the time. And we have to, I think, really be clear in what we're saying. If in the pre-scientific days, the common view of this was that there was some sort of a benevolent grand intelligence that arranged things in the best possible way. And then the message is pretty clear to the scientists: don't mess it up. Everything is great. It's how it's supposed to be. Don't make it worse, right? That was the message. So now we have to decide. If we don't believe that, and if we believe that the laws of physics and the kind of evolutionary processes are what gave rise to the natural world, you have to then realize that those processes do not select for any of the things we value. They don't select for happiness. They don't select for intelligence per se. They don't optimize for meaning in our lives. None of those things that we value are what evolution optimizes for. And so we have to ask, if you're really into natural things and preserving what's natural, you have to ask yourself, what is privileged about the outcome of a bunch of random mutation and then selection events that left us susceptible to bacteria and to lower back pain and to, having the optic nerve come out the front of your retina so that you have a big blind spot that your brain has to fill in, and all this junk. Like, all this stuff was, nobody planned it so that we would be happy. It's just where evolution happened to have left us. So I'm really stumped as to how a lot of people who claim they don't believe in some sort of creation story think that the product of the natural random meanderings of evolution are privileged over what we could do with our rational mind that has these values and can put ourselves to rationally pursue things like happiness and fulfillment of potential and all these kinds of things. I don't know why people prefer things that come out of a random process than ones that come out of a process that was thoughtful. Now, some people may say that the standard story of physics and evolution isn't actually true and that there is some sort of benevolent design behind that. Then you should come out and say that. If you think that that's what it is, that's fine, and I'm not arguing one way or the other, but we should make it explicit, because otherwise what you're saying is you'd rather have the process of a random walk through fitness space than one that was thoughtfully modified by a human intelligence.
I think that's a little different. That's like saying, okay, this is something I hear. I mean, I know is there very much an assumption that what is natural is what is good. And by natural, we mean what is as it is, which is weird. But it also seems to imply that humans aren't natural somehow, or that this process, that whatever is going on here with the fact that we can now become aware of our own cognition and we can create new tools and things, that's somehow not part of that natural flow. I don't know. I mean, that already feels a little bit complicated, but also, I guess what I mean by natural is not the natural way things are so much as looking at environmental concerns, the way that the climate is changing. We don't need to say anything more about who's responsible, but the fact that we're all part of this system, call it natural. But I don't mean by that it's right, just that it is what it is, right? And somehow maybe we can find ways for that system to be healthier. It seems to me that the technology and the ecology, however big of a scale you want to put the ecology, the best relationship is the one where they make each other healthier, not where they're at odds. I don't know. Do you know what I mean? Like, not just the idea that what's natural is good. Let's bracket that, because that's definitely not, I mean, that I think you've well explained, just from what you just said. But when we just think about bigger, so you're dealing with these certain scales of environment and machines, or if you want to call them that, beings. And we could kind of go up and look at something like the way we build a city, the way we manipulate that environment in concern to us as cells or something. I'm being very general. But I do wonder if you see some kind of continuity there in terms of the way that you can, in both ways, right? With the Anthrobots, in the way that you can release individuals to be something different than what they've imagined or been told they are, like a cell. But also in the other way, like with the embryos, where you start to understand how much collective action is important. So I know, this is about speculation, just like trying to see. I just wonder if you see any continuity between these different scales of kind of problem solving.
Yeah, I suspect that some of the same tools are going to be important in understanding the scale up of cognition at many levels. Obviously, environment is a critical issue. I think one of the problems there with just saying that we're going to bidirectionally make each other healthier is that needs to be unpacked, because you could imagine an ecosystem that's like a viral paradise, right? There's viruses infecting everything, and the virus, like, it's a great ecosystem. It's very good.
Good for the viruses, right?
We may not enjoy that very much, right? And you can think about what happened in the early history of the Earth with the oxygen catastrophe. When oxygen first showed up, it killed off, made the atmosphere toxic for a lot of other creatures, right? So that was a natural event, but nevertheless, the ecosystem changed radically. So I think that the whole, even beyond the kind of more primitive notion of natural that we both, I think, crossed off the list in this conversation, just the other aspect of the ecosystem as a singular thing where it's obvious what it is and we just need it to be healthy. Like, I think we really can't help having to lay down some values over all of it, because there are people that believe that animals naturally eating each other is a problem, and that it is our moral duty to engineer them in some ways so that they don't do that. There's some really kind of nasty examples with various parasites and so on, and that may not be in our vision of an optimal ecosystem, or it may. So I don't think there's any consensus or alignment on that among people, and so that's I think a lot of people see natural as a way to gloss over having to make the hard choices
Mm.
about what do we actually prefer. And you can see that a lot of people focus on what they don't want. So people
Mm.
write all the time about all these horrible things that are going to happen. I don't want this. I don't want a future where we this and where we that. It's much more rare to see a positive statement. What do you want? Because, 100, 200 years from now, are we still walking around with the same susceptibility to viruses and bacteria as we had been, or has that been fixed, or what's going on? Are animals still eating each other? Are wasps still eating caterpillars alive, and this kind of thing? And so we have to make some hard choices, because in some sense we're the adult in the room now for the first time. Like, we actually have the capacity to make these choices. And papering it over with this idea that let's just let the natural world be natural I don't think it's going to do it. I think we have to step up and face these issues.
Which is kind of what, like, part of just realizing we're responsible. That, I mean, for me, if we really start to understand that there are continuums, I'm not sure there's one continuum. I wonder what you think about that. There's not dichotomies, there's a continuum, but there's maybe continuums that we have to deal with, in all directions, multidimensional. But we can at least start to understand that we are not like separated from that. And so therefore we can either take responsibility for this stuff and ask the hard questions and deal with it as like almost like as an extension of it, understanding that, that we're an extension of it, or, and then we have to really kind of redesign in a way. Not only things like landscapes, like cognitive landscapes, in terms of law or ethics or whatever, but I think also the built environment, right?
Yeah, sure.
And it seems to me that we might do it in a way, something like what you're doing with the Anthrobots. I mean, I really mean thinking kind of wildly, like what you're doing now. If 20 years ago people would have just said it's sci-fi, some people still think it's, on somehow on the edge. And I mean, maybe we can blend all those categories, but what if we thought about buildings like that, bridges,
Yeah.
all of that? I mean, people are already starting to do that a bit too. And I just wonder, I really mean it literally, if the kind of stuff you're working on could literally be used to build built environments at some point, if you think that,
Yeah, I mean, I'm not an expert in that aspect of it at all, although like the first author of that Anthrobot paper, Gizem Gumushkaya,
Gizem, yeah. I want to
she's
talk to her, actually.
you should
She seems really cool. I
she
mean,
is
she's studied landscape design or something, right? I
she's an
saw in the
architect.
notes.
Yeah, she's an architect, and so she thinks about that stuff all the time, growing buildings and whatnot. So yeah, you could definitely talk to her. But I think that the part that I am able to focus on and is this notion that there are other minds all around us. They're not like human minds, but nevertheless, there are minds all around us. We are very bad at noticing them.
Mm.
We are bad at knowing how to relate to them. We are going to be creating, we already are, but much more so, we're going to be creating them without understanding what we're creating. And so part of that aspect of it, be part of having a good relationship with ecosystems, with our environment and all of that, is understanding at this point, hidden agency in a lot of it.
Mm.
And that's one of the things about AI that I'm excited about, because I actually think if done correctly, it can offer tools to help us see those other minds and help us like almost like a universal translator, kind of. So we
Mm.
have some ideas that we're working on some stuff in the lab for using AI as a translator tool that can help us take the perspective of other kinds of minds, and also to recognize them and to relate to them ethically and functionally. And I think that's an exciting use of that technology, because if we don't understand, it's like any other kind of engineering. If you don't understand the competencies of your material, you're not going to have a good interaction.
Yeah. For me, that would be, I think of that too, of how AI might, and not all kinds of, not like just large language models, but large action models, large world models, all these, kind of things could really, or virtual reality combined with that could actually give us a way of thinking like a bat, in a sense, like experiencing the world from a different position in a way, just understanding the continuity of that trajectory, and understanding we don't understand the whole thing, but that we could get a little more experience of
Yeah.
that.
I mean, it can get really weird if you think about it long enough. Like, okay, what's it like to be a bat? Fine, but what's it like
What's it
to
like
be
to?
data in a self-sorting array? What's it like to be a number? What do, like when we publish these papers, both on biological model systems and computational like models, right?
Mm-hmm.
The paper is always from the perspective of the a scientist, with
Mm-hmm.
a couple of exceptions. So there's a couple of people that have actually done some really neat work that's different. But mostly we just write here.
Sorry, I have to stop you there. There's people who've written papers from positions that aren't human.
Well, so for example, there's a paper called "The Cognitive Domain of the Glider in the Game of Life," and so
Oh.
that paper looks at this. It's a Randy Beer's work, and it asks, okay, so here's this pattern in the game of life. What do you see if you're a glider? What does the world look
Okay, okay,
like? So
okay.
there are people who have started this
Mm-hmm.
kind of thing, right? But
Back to the weirdness.
yeah. I mean, we need to get really good at this and really asking, what does the world look like from all sorts of weird perspectives that we are not used to. In fact, things that we don't think can have a perspective. That's the problem, is that we are so blind to some of that stuff. I'll tell a quick, just this story popped into my head. Oh, and this relates to, you said over time we've things that seem sci-fi. One of the things that I find quite amazing is that people, I think, nowadays either don't read or don't remember sci-fi, because a lot of the issues that we're dealing with now, it's all been dealt with, for the last 120 years. Science fiction
Yeah.
has dealt with a lot of stuff that people bring up to me, these kind of problems. I'm like, that's been gone over so many times, and the imagination is really stifled a lot by not, by not knowing that field, right? So I think we
Because a lot of it actually leads to promising research areas in a weird way. But people
well,
don't want to say that because it sounds like it shouldn't, but it does. I mean, it
and
has.
it stretches your mind. Like one of the blog posts I did recently was a collection which a lot of people on Twitter contributed to, which was a collection of sci-fi stories about love and relationships between radically different alien species.
Oh,
So
wow. How did I miss that?
yeah,
Oh.
like that's really important. So it's a list of, I don't know, 40 books and stories or so.
Oh, okay.
Like that's a really good intuition pump, because people say, oh,
Whoa.
this is a machine, I'm a real organism. Like, okay, but when you find an alien and it's kind of shiny and it's kind of metallic and it gives you a poem, like,
Mm-hmm.
okay, now you're into the hard stuff, because you can't just say one or the other because that's how you feel. You have to actually figure out, how do we tell these things, right? And
Mm-hmm.
so who can you love with that's not just your own kind, right? I think that's super limiting. So anyway, so those kinds of things have been dealt with in that, slightly more right brain kind of way, right? As
Yeah,
the
I've thought of that before, of how certain things that I've read or watched do, sci-fi things where you come to love, feel something like love for a being that's so different from you that it expands your capacity for love, I think.
yeah,
Um,
yeah, and
Weirdly, and when I was watching some of your videos of the Anthrobots, I felt this kind of like, do you know the one where they're in the petri dish and they're all like going around and around? Like for me, it felt like the Charlie Brown Christmas thing, when they're playing or something. I don't know. There's a few moments looking at some of those where I have a kind of tender feeling or something for
oh, no joke.
these
Yeah.
things.
Yeah, I agree 100%. I do too. When I see these things, it's amazing. And we wrote about it a little bit with some of my colleagues about expanding the cone of compassion, as
Oh
as
yeah,
you try to
yeah.
expand your cognitive light cone. I mean, yeah, I think absolutely. As you learn to recognize other sentient beings in novel guises, it helps you expand that, right?
Is that
Um,
part of what you're trying to do with your word use sometimes in your language? Because, or not only you, but here's a place I could probably start with it. The Biobot. That's kind of an older term, I gather. Not older, but 10 years or something. But I wonder when that kind of started. And because a lot of times people hear robots and they think metal, or like some kind of material that's not biological. And of course, you're creating synthetic biological robots. But let's start with Biobot. Where did that come from? And then, so Anthrobots and Xenobots are kinds of Biobots, I guess. You often talk about them as machines. I wonder about your language use. I know for you, it's not different, but like, yeah, let's
well,
start with the Biobot.
yeah, so let's take a step back. And part of it is that different words are more or less shocking in different communities, and
Yeah, yeah,
right, they subvert the expectations, or they seem perfectly reasonable to
yeah,
different communities.
right. Good point. That's
My
kind of what I'm trying to bridge here with the.
Yeah. Let's one fundamental philosophical perspective that I have that's important to understand how I use these words is that I don't think any of these words are claims about the system themselves. So
Mm.
I don't believe, so some people say, okay, is it a robot or is it a living organism? And I don't think those words are about the thing itself at all. Those words, what those words indicate are your reference frame and how you plan to interact with the system. They are engineering protocol claims. So when
Okay,
you
that's really interesting. So it's about your orientation, your goal of why you're
it's
looking at this.
it's about a perspective, which is like a collection of commitments to what you're going to ignore, what
Okay.
you're going to use, how are you going to think about this thing.
So it's not the thing itself. You should always realize you're not. Yeah. Okay,
Yeah,
that's
I
important.
don't think any of these things are claims about the system itself. I think when you use these words, what you're saying is I have taken a particular stance towards it, and that stance, let's understand, that stance is going to facilitate certain things I can do, and it's going to block me off from other things I can do. And we should be able to move between stances as needed, and we should have a mature science of how do you pick more or less appropriate stances.
I think that would solve, or that would be so helpful if we could just learn that. I'm gonna skip over it, but I just had to say that. But yeah.
Yeah, I know. I think it's critical to understand that this is not something that you can assign to a system. It's how you see the system. I'll give you a dumb example, and then we'll talk about the bots.
That's something reading helps us do too, by the way, right? Taking on other positions and understanding that that's what we're doing. But anyway.
Yeah, so like here's a super simple example. The paradox of the heap, right? Let's define what a pile is. And well, I take off a piece of sand, and is it still a pile? So if you think the word pile refers to the sand, you've got a philosophical conundrum, and you got this paradox. The way to get this paradox is about the sand. Is if you tell me you've got a pile and you want to move it, what I want to know is, am I bringing a spoon, a shovel, a bulldozer, dynamite? What am I bringing? And that's it. It's all about.
So the terms are the spoon, the shovel, whatever. Yeah. Is that what?
So if you spend all night wrestling with whether it's a heap or not, it's waste of time. What you should have been thinking is, okay, so this is an object that is amenable to which tools, which frame am I going to use for this, right?
But I guess what I'm asking is robot, those kind of words, machine, are those akin to something like the tools that are being used in this?
Precisely.
Yeah.
So so let's get to
it's not the thing, it's not the heap, it's what you're using to do what you're doing. Yeah.
Correct. Okay. So when I call something a bot, what I'm drawing attention to, I'm not making any claims about what this thing really is. In fact, I'm not sure there is any such thing as what it really is.
Right. Essence, we can leave essence behind.
No, not even from its own perspective, right? Because these systems, they also have their own perspective on what they are. And
they're always changing. So, I mean,
they're always changing, and they have multiple ones. Okay, so when I call something a bot, what I'm signaling is that there is a set of interactions that we can have that will let you control its form and function. So for the biomedical perspective, so the bioengineering perspective, I'm saying, look, this thing is a bot, a biobot, because we will be able to control its behavior and make it do useful things. When I'm talking to a collective intelligence or cognitive science crowd, I would say, and I haven't done this yet because our work on the cognitive properties of these bots is not yet published, so I don't make any claims yet about their, but once it's all peer reviewed, like you'll be seeing all this stuff, then it's a completely different story, because this thing's a proto-organism as well. And why? Because you can take a stance where you say, forget programming it as a biobot. I want to know, what does it want? What kind of memories can it form? What preferences does it have? What goals does it have? That's a completely different stance that lets you do very different experiments than if you have a bot perspective, but both of those are useful. And we do this all the time in medicine. If you have an orthopedic surgeon who doesn't believe that your body's a machine, you're in big trouble, right? Because what he has is chisels and hammers and screws and things like that. And if he doesn't understand that your body's a machine, you're not going to have a good orthopedic outcome. On the other hand, if you have a psychotherapist who thinks you're a machine, you're also not going to have a good outcome. And so
that's a very important what you just said. I don't think a lot of people understand that nuance in your.
But people argue all the time, are we? Whole conference is devoted to the fact of whether we are machines. And my point is, no, nothing is anything. It's about what you're proposing, a perspective, you're proposing an interaction frame, and then we all get to find, then that's what makes it empirical. So that's what I love.
An action frame, right?
Once you've proposed it, we all get to find out how well that works out. So if you have a deep psychological frame for looking at a mechanical clock, what we're going to find out is you're wasting a lot of time. But on the other hand, if you have a frame of rewiring that's appropriate to mechanical clock, and you're applying it to a complex organism, or frankly to a robot, or possibly even to a language model, you may find that you're leaving a lot of stuff on the table that you're not understanding. So that's what
That is
makes it.
really important, Michael. Let me let me say it again and see if this is right. So if you're coming at it, if you're in the lab and you're going to do something like what you've done with the Anthrobots, that's programming in a way. So they're bots and they're machines. But when you're just walking around taking photographs in the morning early or whatever, you're not like thinking of everything around you as a robot or a machine or something.
For sure, because in that interaction, I'm not looking to control anything, right? So the bot, the thing that the robotics perspective is really good at is facilitating control. So if you want to understand how to control a system and make it do something it doesn't already do, that's a machine frame, that's a robotics frame. That works great for a lot of things. And in fact, it should be used more for things like cellular constructs and so on, right? Great. But there are many other scenarios in which your goal is not to control, your goal is to have a bi-directional interaction. And with your friends, with your spouse, with whoever, you're not in that frame because the reason that you take a human person with you when you go to Mars for 30 years rather than the Roomba is because you want a two-directional interaction. You want to be vulnerable, you want to benefit from their agency. So on that side of the spectrum, it's a lot less about control and a lot more about bi-directional connections. So there are many times when I think about Xenobots and Anthrobots and all of these things, and I don't think about them as biobots at all. What I think about is what do they want? What is it like to be a biobot where you are out of the normal body? A lot of your priors are now being rewritten. What is that like? And we do experiments in this. For example, we're checking the stress level of these bots in different scenarios. What are they stressed out about? What are they what are the goals that they can pursue? And again, none of this is published. I haven't made any claims on any of that, but those are the kinds of questions that were asked. So and certainly when I'm outside in nature or when I'm talking to other beings, that's usually not the frame I'm taking. But when I'm thinking about when somebody calls me and says, I've got a spinal cord injury or a peripheral neuropathy, and what are we going to do about this? I'm thinking, yeah, can I program the Anthrobots to go in and fix that neural scar, which they seem to be able to do some of that.
So it's really a mode of action. It's not, as you've said again, but I think it's important to say you're never characterizing whatever it is that's either asking you the question or that you're looking at in the lab or whatever. It's more for you a mode of action of how to best problem solve or something, or best be in that situation if you're not problem solving.
Yeah, it's just fundamental humility. I mean, like, how can anybody really think that they can what something actually is once and for all? I mean, we're all finite beings. We all observe the universe through a very thin keyhole that was shaped by evolution, and we have not just senses, but a spatiotemporal scale and a cognitive system that was shaped for in very particular circumstances. Does anybody think that we have the apparatus to once and for all nail down what something is in and of itself? I don't. And so what's left to us is to come up with practical, empirically defensible frameworks, and they can all disagree with each other, and that's fine because they will all be useful for different purposes.
Yeah, they don't even have to disagree with each other if we actually take that seriously and understand that it's for each kind of trajectory that you're on or whatever the goal is that whatever situation you're in, the situatedness will always demand a slightly different orientation. I mean, just it has to. I mean, we're all
it will suggest it will facilitate different perspectives. I want to emphasize one other thing, because some people take this view both in good and bad directions as anything goes, and
you could take it too far to like relativism or something.
Well, some people say, could we think of the sun as a great intelligence or the galaxy as a great intelligence?
Okay.
You can make the hypothesis, but then you have to show what does that get you. So the difference between like old school animism, where you just say there's a spirit in every rock and that's great. Like, okay, the next question is, what did that buy you? So I show me the beneficial interaction that let you have, and maybe it did and maybe it didn't. And so I want to be really really clear that my view isn't just you get to paint whatever level of agency on anything you want. My view is make the hypothesis, make a clear specification of what you think it's going to do for you, and let's all find out whether that worked out for you or not.
I think that's why I always try to locate like whatever the position is or the agent in a particular landscape in a particular trajectory. I mean, you do that too. You're all in a different way, but because it's never some kind of in the same way that you don't try to that you're expressing now that you don't name the living system, or pretend to know what it is even, but you're studying it. There's always an orientation through which you're coming to discuss something. So to make some generalized statement that like the sun is intelligent doesn't mean a lot. I don't know. I mean, it would have to be like, what's the issue that we're discussing, and then how does it, what does the intelligence mean? And yeah, as you said, what is it doing? Um, but a
You have
lot
to
of
make it
this, yeah.
you have to make it testable, right? So like somebody said to me once, well, these all these diverse intelligent views, you might as well say that the weather is intelligent too. Well, I wouldn't just say that, but you could make the hypothesis. Have you tried training it? Like, are you sure that hurricanes don't habituate, or that there isn't some kind of sensitization process that if you had the tools, now obviously that's very difficult empirically, but like experimentally, it's hard for these large systems, right? But the thing is, we have a behavioral science where you get to find out what the level of problem solving is of various things.
Mm-hmm.
And that's the experiment. You should do an experiment if you think, and a lot of these are outside of our technical capabilities, but at least in principle, if you thought the sun was intelligent, you would specify what problem space you think it navigates, you'd make a hypothesis, and you would do a perturbative experiment. You can't do this with observation alone. You would have to do a perturbative experiment and say, oh, look at that. It actually did, get from here to there in this problem space, even though I placed a barrier. And we do this all the time with wacky systems. Like we apply this to very simple things where you would say, oh, that's certainly a dumb kind of mechanism. It doesn't have any intelligence. We found problem solving capacities in
Like a slime mold or something, or what do you?
way simpler than that.
Oh,
Sorting algorithms, like computer
oh,
sorting,
wow. Okay, okay.
like bubble sort, 6 lines of code. People have been studying it for decades. Everybody thinks they know what it does. It has novel properties that are not in the algorithm itself at all. And it can do something, I mean, simple, primitive, but still, like, you wouldn't know if you hadn't asked. And similar to gene regulatory networks, we find 6 different kinds of learning, including Pavlovian conditioning, in very simple pathway models, deterministic, no stochastic effects even. Already they can learn, like, no, just super simple. So my point is, you have to do the experiment. You have to make a hypothesis and do the experiment and see what evidence of, for example, problem solving you find.
Yes, I think that's the engineering approach, and it's crucial. And of course, I'm working in more theoretical and philosophical, so I have to be even more careful. But I do think there's ways in which, for example, having studied neuroscience, working toward in psychiatry and so on, you can actually see if these ideas help people with certain issues, or like that's why I started with the environment in cities, because I've worked in motoring a lot, or how we design our cities. And you can understand that the way you explain something to people can literally change the openness to which they're willing to participate in a new kind of design, for example. So I'll just bracket that because it would be a whole other discussion. But as you were talking, 2 things came up that I want to talk about before we have to go. And one is the idea of like personalized medicine. Um, but to get to that, I want to start with the idea, something that's very striking to me and can seem dichotomous about the Anthrobot paper and the embryo paper, the more recent ones, which I'll link to because we don't have time to just like go into what it all is. But is in a way they're almost this is beyond dichotomy, so it's not a dichotomy. But as I was reading both of them, I was thinking in one of them, in the Anthrobots, how it's about like individual freedom. I'm philosophizing, but in a sense, you're kind of you're releasing the cell and like seeing what it can do when it's not stuck in this like inertia that it's stuck to the expectations of others, so to speak. And then in the embryos, we're getting this idea of like the one embryo frog embryos, by the way, right? Yeah. Can't can't survive by itself. So you get this groupthink idea where it's actually the collective that is the powerful thing. I wonder, yeah, I just want to bring that up, because I think it's very rich in the power of releasing the individual, but the individual also always being part of a wider system. I wonder how you see it, like as you were doing the research with those papers.
Yeah, I think this is fundamental to biology, and it isn't magic. I think we can build system. We haven't yet, but I think we could build systems with that architecture. But in biology, every level has a degree of goal directedness. They're all trying to solve certain various problems, and they're all hacking each other with like horizontally within the level and up and down. When we were doing that, the frog embryo communication idea, yeah, I'm interested in this notion of a hyperembryo, and I mean, we show that these groups, large groups of embryos, have their own transcriptome. They have their own gene expression that small groups don't have.
Incredible.
That
I
that
mean,
hyper
both papers totally incredible, mind-blowing stuff about what's possible, I think, but yeah.
Yeah, and this is another example. Until you check these things, you don't
Yeah.
know.
Yeah.
And
And who imagine, I mean, there's probably so much we don't know. I mean, I'm sure
yeah,
you've said that a million times.
yeah. Would you? Oh, we're definitely just scratching at the surface of this, but
Mm,
already, if you have the right mindset, you can do the experiments, and this is why these frames are important, because if you have a particular frame, you do or do not do certain experiments. People
yeah.
often
Yeah.
say like, okay, that was great biology data, but what's with all this like, get rid of all this philosophy and just do the science. Like,
Mm,
well, guess what? We wouldn't have done the science. Why did nobody else do this? Because we
right.
didn't need a
She
particular
thought
frame,
about it.
right? And
Mm,
that's the thing, like some people for the Xenobots, some people said, oh, well, they're embryonic and they're amphibians, and we know those cells are plastic. This is just a piece of developmental biology in a frog. They're animal caps. People said you shouldn't call them Xenobots, you should call them animal caps, because that's an old developmental biology term for those
oh,
cells, is an animal
okay.
cap. And the thing is that, okay, but if you call them animal caps, guess what you will never do? You'll never make Anthrobots, because you see this as a piece of developmental biology in frog. You
Because
would
you've
never.
oriented yourself, you've put certain parameters that you assume can't be changed.
Yeah, from that perspective, this is a piece of natural developmental biology in Xenopus, and you wouldn't look for it anywhere else. Whereas if you're thinking of this as a biorobotic system, or you're thinking about this as a plasticity system for collective scale up of collective intelligence, then of course you say, no, all cells should be able to do this. Let's get as far away from, that's why we went human, because we wanted to get as far away from embryonic and amphibian as we could. And what's the furthest is an adult human patient.
Right.
And the way that leads to, you mentioned the personalized medicine, right? It's because these are constructs that are made from your own body cells, that they're not genetically manipulated. They don't have any viruses. They don't have any weird nanomaterials. They don't require immune suppression. If they were to go in your body to fix things, they would not require any immune suppression, because they're your own cells. And these cells share with you all the priors about what health is, what disease is, what inflammation is, what cancer smells like, all of those things. You don't have to construct them the way that you would with
It's
conventional
already embedded. I mean, it's
nanobots. Yeah, they
coming
already,
from.
yeah, it's coming from you. They already understand that. But we have to learn to take advantage of that. We have to learn to communicate with them through their interfaces.
Yeah. I've been reading about personalized medicine for, I feel like, as long as I've been learning, and it feels like it's the way to go in medicine and psychiatry and everything. But how far do you think we are from having the infrastructure or the mindset or whatever? First of all, what do you think it takes to get there? And how far away are we from being able to do it, do you think?
Well,
Speculation, I know, but
yeah, I mean, it depends what you mean, right? Because there are low hanging fruit, and then there are kind of like this
well, it's
definitive.
already changed a lot. But I guess what I mean is really being able to orient certain kinds of medicine to the individual through, yeah, what you're doing in a way.
Yeah,
Letting the body speak for itself.
oh. The kind of the first tier aspects of this are already here, and they're going to be here within this decade, which is basically all the incredible number of new sensors being developed
Hmm.
and AI to
Hmm.
process that information and to say, for you, this is the pattern that's going on with your whatever physiological measurements. Like that stuff is already here, and it's going to be, exploding in the next few years in the decade. The slightly deeper thing, which I hope also won't take that long, is to go beyond, again, okay, you're still a clockwork, but now we're measuring a whole lot more parameters, which is
Hmm.
great. But the next step is, yeah, but you're not just a clockwork, and all of these things have
Hmm.
preferences and goals and competencies, which is why a lot of drugs stop working or don't work at all or cause side effects, because
Yeah.
you have
And you're
gotten the.
changing too. So I guess that's what I mean too. How sampling constantly and kind of itself a dynamic system, the personalized medicine. But
Yeah, I mean, a lot of it is actually, it's funny. The more you get to, the more you can take advantage of these cognitive capacities in your cells and tissues, the less you have to worry about the noise, because they're already
hmm,
once the cells
yeah.
have shifted to a new homeodynamic pattern, meaning that their goal state has changed, they're already good at maintaining that goal state when different things happen. That's
Mm-hmm.
what, that's what life does. And
Mm-hmm.
so you don't have to be there and saying, oh my God, the pH is slightly off, my drug doesn't work anymore,
Mm-hmm.
because that's not the level you're going to be working at.
Yeah.
And that's what's going to be truly personalized medicine, is not just personalizing it to the state of the body, but actually communicating with the individual goal-directed set points,
Mm-hmm.
and able to get the buy-in of the cells. Like, what, with the exception nowadays, with the exception of antibiotics and some surgeries, we don't have anything that permanently fixes anything. Right? You take these drugs, they target the symptoms. If you're lucky, they do a good job. The minute you stop taking them, you're back to where you were or worse. Right? They don't actually fix. We have very few things that actually fix anything. And that's because you're micromanaging a very a complex goal-directed system where the cells try to fight you. That's where all these crazy side effects can come from, is that you haven't changed the set point so that the cells are working with you to maintain a new set point. You're just, you're trying to prop it up, bottom up.
Yeah, and there would be so much. What I also hope is that we can connect trajectories between generations too, but that's getting into a whole other thing. But I do, when you were discussing this, I was thinking about something I've read in different parts of your work where you talk about, I think you were talking about a new book that just came out about the struggle inside the body of the
Yeah.
cells struggling. It was in German, but I think it's been now Harvard published. I can't remember the guy's name, Wilhelm something.
Wilhelm Rook. Yeah, it's
Wilhelm
actually
Roux.
a very old book. He's a classic embryologist. It just got translated.
Yeah. And so, I mean, I just want to ask, throw it out there. Do you think competition has to be about struggle? And if yes, does struggle have to be about suffering? Are these linked? Because there's this, you've used the term hacking a lot, and there's this kind of aggressive sense that's very real. But then also you're often talking about working together and this collective action and so on. And these again aren't either ors, but they can also often sound like it. So I want to open that up a little bit. Like, so the book is basically saying about the struggle between different parts of the body, right? That's part of life, or you can describe it better. But I wonder how you see that, if it's really about struggle, and if struggle, there's something in your writing where I think you say there's something wonderful about fragmentation and struggle if you look at it from a certain perspective. And that doesn't have to mean suffering, right? So I don't know. Well, how have you thought of those things, if you've thought of them?
Yeah, so I think of it as two sides of the coin, which is, as a persistent agent in this world, whether naturally evolved or engineered or whatever, if you're a successful agent in this world, you are going to be homeostatic, meaning that there are going to be some states that you prefer in whatever space you live in. There are going to be some things that you prefer. And for you to survive, you are going to have an innate stressor where you are far from those states. If you really don't care about what state you're in, then you're a photographic film. You're not a being. You're not an observer.
Is that like connected to movement? I mean, when you're talking about that, I think about the difference between something like an Anthrobot and an organoid.
No, so this is important. I'm glad you brought that up. So
Okay.
organoids, I think, okay, so here's the thing. People are too fixated on three-dimensional space. So a lot of minds and a lot of agents live in other spaces. So they live in
Important
anatomical
point. Yeah.
spaces, they live in transcriptional spaces, physiological, metabolic. All of
Mm-hmm.
those things do not look like intelligence to us, because we
Yeah.
are so fixated on, with our visual system and so on medium-sized objects moving at medium speeds through three-dimensional space. That's what intelligent looks like to us. That is a
Mm-hmm.
tiny sliver of what the worlds that agents live in. And
Yeah.
so chose Anthrobots precisely for this reason, because people are not yet comfortable viewing these other spaces, but we are doing all kinds of work, and we're building visualizers so that you can actually see why your liver and your kidneys, for example, are an intelligent agent navigating physiological space. But we need a visualizer.
Wonderful. Wonderful.
We can't
Mm-hmm.
see ourselves. If you are any kind of a successful agent, that means that you have very strong preferences about what's going to happen. And that means that if you're deviated from those, you're going to be unhappy, and you're going to have stress, and you're going to have some depth of suffering over it. And of course, that can get very complicated. But I don't think you can get away from that, at least in the embodied state. I don't think you can get away from it. But the issue of, again, cooperation and competition, it's different frames that you take to observe these things. And both of those things are really valuable strategies for cognitive glue. They're both strategies that evolution uses to make these agents. So yes, there's a bunch of competition within this. Yes, there's a ton of cooperation with this. It's up to you as the observer what frame you're going to take and what does that do for you. So if you look at everything through a competitive lens, you're going to see certain things and you're going to be blind to other things, and vice versa. And so I think those are two sides of the same coin, because when you try to, so look, as an agent like this, signals from others are coming in, and you have a hard choice to make. You can fight them, you can resist them, because let's face it, if you go with every signal you get, you're going to very quickly disappear. You're going to be parasitized, and the environment is constantly trying to kill you in that sense, right? So if you're completely open to everything, you're done for. On the other hand, if you are completely invulnerable to those things, if you never change anything based on signals you get, then you're a rock. You're not, you might be persistent, but you're not very interesting. So
Right.
all agents face this dichotomy of, when do I view this interaction as a hacking, and when do I view it as a pleasant interaction that I'm benefiting from? And you have to learn the difference. It doesn't come pre-labeled. And it's the difference between learning and being trained. Like, am I the boss and I'm learning, I'm going around and learning things? Or wait a minute, is there another agent and I'm actually being trained when I'm learning, right?
Do you mean that in like a system one, system two sense of kind of
well, you don't
dual
know.
process kind of?
So as a creature, you're in the environment, you don't know how much agency there is in your environment. You have to infer that. You have to make a model, and you have to say, okay, I live in a dumb mechanical universe. I'm the agent, I'm the boss. I get to learn whatever I want to learn. Or you might say, wait a minute, I think there's a pattern to what's going on here. I'm a neuron in a brain. There seems to be, yes, there's a local environment, but I'm getting some evidence here that there are like global patterns that are in charge of this. There's another agent out there that's in control of my environment, and that might be training me for who knows what the agenda is, right?
Right. But of course, often the body is the model. I mean, there's a difference between the body being the model, aligning, shifting its parameters in this very immediate sense, than something like us where we reflect on this and then choose. Or is there?
Well, so certainly we have an extra capacity to reflect on things, but even very simple things, well below the level of whole cells, build models of their environment. They're not self-reflective models. At least we don't think they are. It's hard to know, actually. But the simple models it's still the case that anything that persists over any significant amount of time has to have a model of its environment. Otherwise,
Yeah, we don't have time to go into that because I think it's like a representational debate where I really think like if you're changing your biology, and that is modeling the environment, but it's not that you've like built a model and you're looking at it. I think this gets very confusing, but anyway, just continue with the point because that would be a major
yeah,
aside.
I think that's it. I think we can do that maybe next time,
Yeah.
but making a binary line between just being a model and being able to apprehend that you are actively consulting a model, I don't think that's a sharp line either. And I think
No,
it's very,
definitely not, but there is a difference. There are some that are models or modeling as part of their activity, and there's some that are aware of their models to a different degree. I don't think there's a sharp line at all, but I think it gets all lumped together and confused in really fascinating ways. But again, that would have to be another conversation. I want to hear you finish this point, and I also, just before we go, want to get a little bit to think about death and because you said something at the beginning about that evolution doesn't care about happiness and so on and so forth. And I know one of your main motivations is helping people who have a lot of suffering, which is kind of why I brought up this hacking and stuff, because people are suffering and we don't say that's natural and right in the sense that
some
we bracketed at the beginning.
some people,
Yeah. So
I get emails, it drives me up a wall, but I get emails, and mostly these are young, healthy people who haven't had kids and or haven't had any medical issues, don't
yeah,
understand.
yeah. Which, I
But
mean, that's just their trajectory. Part of this is them learning about that, we hope,
yeah.
but they send you emails saying,
Well,
what are you
so I get
doing?
a wild mix of emails, but some people say, hey, look, this isn't natural. Let's not do that. And, and meanwhile, they've got they've got a bicycle and they've got some glasses and they've got all this other stuff. Like, I
I
mean,
think they're just scared. They're just scared that the equilibrium will change and they don't understand, the suffering. But I just, we have to go. And I do want to, like, would you really think if we take ourselves, if we bracket that whole everything is natural idea, let's like leave that away. And we're part of this living system and we're becoming aware of ourselves and our own models and so forth. Do you see a role for not happiness? I mean, that's too generic of a term, but for at least like finding ways to help one another deal with our suffering? Because there are, as you know, there are some points of suffering where you can't just relax and sort of go with it. And fighting it doesn't help either because it makes it worse at this point. So do you see that as part of the motivation of what we're doing? Of
Yeah.
evolution too, because we're part of it.
Well, absolutely. So look, I don't have any expertise to be talking about, psychological suffering or so society or any of that. I just know one thing, that all of that stuff is very difficult to think about if your embodiment is distracting and terrible. And so
Yeah.
the only thing I really know is that there are many beings who, through no fault of their own, have been thrown into a really suboptimal environment. And there's this notion of the Buddhists have this notion of an inauspicious birth. And I sort of think right now, every birth is an inauspicious birth because we have these limitations born that are driven by genetics, by, a stray cosmic ray, by drugs that were around, by all kinds of stuff.
Yeah.
And step one is freedom of embodiment, is to fix all that so that, and then we can turn our attention to, more deeper and profound things, which other people talk about. I don't, that's beyond my pay grade in many ways. But I think that, yeah, absolutely none of those deep and interesting things are going to happen while people are suffering in chronic pain and, with all the limitations that we're born with.
Okay, last question. Patterns, are they important to you? I wonder if you have trouble getting out of linear thinking when you're thinking of scales. Do you often think from high to low? Because I find myself still doing this. Or are you able to think multidimensionally?
Wow, I think that's a separate conversation. Yeah, we can talk about that at a different time.
All right, Michael, I hope you have a wonderful day there.
Yeah,
appreciate
thanks.
it.
Thanks, you too. Yeah, always a good conversation. Thank you.
Yeah, it's fun. I'll see you next time.
Okay, take
Be
it
well.
easy. Yeah. Bye.
Bye.